Uh, yeah, we also have common problems with the global position satellite. I think there are things that need to be clear here. We have the global navigation satellite system, and under the classifications, we have GPS. GPS is for the United States. Beidou is for the Chinese. Galileo is for the European Space Agency or the Union. And we have the QZS that belongs to Japanese. That is the JAXA. And also we have GLONASS that belongs to the Russians. Okay, Indians also have their own. I've forgotten the name, but yeah, they also have their own global navigation satellite. But let me talk about the GPS because that is mostly used in many of the commercial um, industry or whatever thing that they are doing for their activities. Right, right. So one of the most common problems that occur with any GPS is the correct tracking, right? So you can see sometimes you want up to date navigation service, like just think about the Google Maps, and that has the ability to actually do the pinpoint, right? Pinpoint your location within like 3 to 10 meters accuracy, right? So this position works best in ideal conditions, meaning you are located in a city or preferably a major one that is maybe living in an open space where you can able to have full access to the 8 or more satellite constellation that can able to give you that high accuracy or the high precision you want. And so the question is, what causes a sudden change in accuracy when the tracking application was working correctly 30 minutes ago, for example, right? In short, it is often about a GPS signal. Yeah, yeah. It's often about the GPS signal, and these signals have to travel huge distance. You know, global navigation satellites are normally these kind of global navigation satellites, and so these signals have to travel huge distance through the atmosphere from multiple satellites to reach your mobile phone, right? In most cases, they do it via special devices. Yeah, yeah. And the quality of such signal plays a major role. Right, right, right. Yes, yes. So the problem is that your device needs to receive strong signals from at least, like I said, for high precision or high accuracy, you need 7 to 8 satellites. Yes, yes. At a time to provide the most accurate location data. So this is why it is best to be most of the time, it outdoors. If you desire the best signal possible, you should at least aim for this kind of number of satellites so that you can have a precise location. Yes. So with this way, your device won't meet as many barriers on its way, and it will have an opportunity to receive the closest and strongest signal, basically. Yeah. And in addition, both urban and natural, yes, 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 yes. So we have what we call the multi-path propagation. That means when you have large buildings in cities, trees, mountains, yes, they can also affect the signal. Right, the signal transmission directly to your device that has the GNSS receiver. So if a satellite is not directly overhead in these locations, it becomes much harder to also track the accuracy. Right, right, yes. And in other words, the more open sky view you can get, the likely more accurate signal you will receive. And the other common method to track with GPS is with a cell phone or the other supportive network like the LTE, the 4G enabled devices, like on your iPad or Android tablet or whatever. Yes. So for precision, most of the times the GNSS receivers that is on our phones are actually supported by these cell phone towers and base stations. Right, yes. So these devices can be tracked with relatively good accuracy. So as you travel, you move from one cell zone to another. Base station monitor the strength of your phone signals, and as you move towards the edge of one cell, your signal strength diminishes, right? Yeah. Sometimes if you play with your phone, you can able to see how the signal strength varies. Or if you check about, if you check your settings about your phone, or you try to go deeper to see your receiver sensitivity and all of that, you can receive some of these values. And at the same time, the base station in the cell you are approaching can notice the strength of your signal increasing. So as you move away from cell to cell, the towers transfer your signal from one to the next, and the distance between the receiver essentially determine your position. So, however, this process also has its drawbacks. In remote location, towers may be so far apart that they can't provide consistent signals, right? Yes, so for example, if you are in those Dubai areas where you are going for sightseeing and all of that, sometimes it becomes challenging, right, to have a full accuracy of your services that is being provided to you. I mean the inaccurate position, basically, right? Yeah. So even when towers are plentiful in major cities or population dense areas, challenging topography and tall building can interrupt the signals, like I said already. And since obstacles like trees and buildings can affect how long it takes your signal to travel to a tower, this method is often less accurate than a GPS measurement. So even without a proper GPS receiver, cell phones and tablets and so on, these can provide at least some good information about your location, right? Because your phone also have some memories that can able to, with the help of the mapping system, it can able to at least give you a history about your location, and with that you can also use your mind to also judge whatever the location is. Yes. Yeah, that's a very good question. Africa, we don't have a global navigation satellite yet. Yes, we don't have. As far as I remember, we don't have. Yes, but all the, like I said, America uses the GPS, GLONASS is from Russia, China, they have the Beidou. In my next presentation, when I'm given the opportunity, I'll throw more details about these countries and their, their global navigation satellite systems. Yes. Right, yes. Yes. So please, we need that money for Africa to also have a constellation of a global navigation satellite so that we can broadcast signals to dedicated phones that are being used in Africa, or devices that are used in that has a GNSS receiver embedded in it for our day-to-day activities. Yes. Right. Yeah, thank you very much. Thank you. Yeah, I hope you enjoyed today's discussion, right? Yes. Thank you very much. Yeah. Bye-bye, guys.